I per aconseguir accés a l'espai, no podem només focalitzar-nos en els satèl·lits, sinó que un element clau és l'augment de freqüència en els llançaments, la reducció dels costos en les operacions i l'augment de la flexibilitat en tot el sistema, en tota la cadena. Sovint s'oblida de la importància dels llançadors i dels ports espacials, que representen un gran cost respecte al cost total de totes les missions. Catalunya és des de fa temps un actor de referència en el sector, amb empreses consolidades i tan representatives com GTD o tan inspiradores com Pangea, Aerospace. Així doncs, dono pas a una fantàstica taula rodona, moderada per Helena Carré, cap de l'Oficina d'Infraestructures de l'Institut Especial d'Estudis Espacials de Catalunya, on es parlarà de la perspectiva internacional del sector dels llançaments. Endavant.
Bé, hola a tots, jo em dic Helena Carré i soc la cap d'Infraestructures de l'Oficina Catalana de l'Espai. En aquesta taula rodona us proposem parlar sobre el segment de llançament i les perspectives internacionals, ja que des de l'Oficina Catalana de l'Espai, justament amb Aeroports de Catalunya, impulsem l'ús de les instal·lacions de l'aeroport de Llairó com a spaceport. Els dos motius principals d'aquest eix de treball són, d'una banda, el fet que existeix una demanda creixent degut a l'increment del nombre de satèl·lits que es preveuen llançar els propers anys i, de l'altre, el fet que a Catalunya disposem del talent necessari per explotar comercialment unes instal·lacions d'aquestes característiques. Actualment, els nostres esforços s'estan centrant en el desenvolupament del centre de motors de proves coet i del parc empresarial al voltant de l'aeroport. Llavors, avui ens acompanyen aquí en Xavier Llairó, que és cofundador i director comercial de l'empresa Pangea Aerospace, una empresa que ja està fent servir les instal·lacions de l'aeroport de Llairó per testejar els prototips dels seus motors in-space. La Victòria Montag, que és gerent i enginyera de UK Launch Services del Regne Unit, i l'Eduard Diez, cap de projectes de GTD. Llavors, la conversa, com veieu, hi ha una persona de fora, llavors la farem en anglès i al final us deixarem uns minuts per si teniu preguntes. So I'm going to now switch to English and I will let yourself introduce. I don't know who wants to start. Maybe Xavier?
Yeah, okay. So hello everybody, thank you very much for the invitation. At Pangea Aerospace we develop and lease propulsion systems both to leave space, move in space and come back from space. We are focused mostly on Aerospace engines, which is an old concept that we kind of relooked at and we made it possible because it's an engine that is more efficient. Basically, you need around 15 less fuel to bring the same mass to orbit, or in other words, you could increment your payload capacity. And we actually last year at the Lampershausen, a facility in Germany, we tested the first European Aerospace engine ever, and we succeeded. We fired it 9 times, more than 5 minutes of cumulative firing. It's an engine that is more sustainable because it uses liquid methane and liquid oxygen as propellant, that is designed to be reusable. And very importantly, just because of the shape of the engine and because it's regeneratively cooled, so we use basically the propellants to cool down the engine as well, it allows you to come back from space in an easier manner. The last element here is that the 2-ton engine that we demonstrated is the first path to a larger development of diversified products. So now we're working on 30-ton engines, but we also won contracts both from the French Space Agency, CNES, and European Space Agency to go to larger thrust engines because the potential of such engine increases as you increase the thrust. Last element here, we are also developing in-space propulsion, so as I was saying, to move in space for satellites and other spacecraft, always with the same philosophy. Very high efficiency and sustainability. Unfortunately, these engines cannot be reused because it's very difficult to to make a satellite come back, but it will be possible one day. Thank you very much.
Yes, yes. Yeah, Victoria, go ahead.
Hi, so I'm Victoria Montag. I'm General Manager and Senior Engineer at UK Launch Services. We're a small consultancy based in London and in Scotland, and our work is to support space flights in the UK and increasingly around the globe. We don't build anything, fortunately. We work with government institutions, launch service providers, spaceports, orbital operators, insurance, lawyers. We kind of sit in the middle of the spaceflight ecosystem, and we basically help facilitate and manage those interactions, very, very complex interactions between all of those parties.
Go ahead, Eduard.
Okay. Thank you much. I'm Eduard Diez, responsible for projects for research and development at GTD. GTD is a company of, I think it's in February, we're going to make 3 years in a 3-year company. It started as a ground segment company, and most of the projects are done in the CAG, in the European Spaceport. We also work with onboard systems for launchers and for satellites and for payloads. It's mainly a systems and software company, as you may or not know, and it has different international perspective in Barcelona. It has also companies in France and Germany, and a team based in the European Spaceport at CAG permanently, and updating and maintaining the systems that GTD developed there. For how long now? For the last 10 years, and advancing something of the first topic, I guess, we've introduced in the, being a classic, I think maybe the most classic company here, old space. We've been, for the last 10 years, introducing the new space market, the new space domain from the ground segment point of view and from the onboard perspective. Mostly in the onboard perspective, because it's been quite a close domain for big companies like Aerospace and other big companies, and that shake in the board that make the new space create an opportunity for companies like us to go in the new space for different domains rather than the ones we are used to and the ones we are more commonly working.
So exactly, the first topic I would propose here is to speak about this transition that we're living, launchers versus micro launchers. According to your experience, what's this change of paradigm that we are living, and where are we going to? I don't know if someone wants to start first.
Well, it's quite exciting for us in the UK because we have our first launch vehicle.
Yep.
It's currently in Cornwall, which is in the southwest of England, and I believe the payloads are being integrated as we speak. I'm not sure when the launch is actually, because as far as I'm aware, they don't actually have a license to launch, but I'm sure it'll be fine. But the real shift is the first payload that was integrated into Launcher 1 was built by a company called Spaceforge that's based in Cardiff, in Wales. And for them to get their payload onto a launch vehicle, they literally had to drive down the motorway. So they didn't have to send, package it up and send it to Peru or Kazakhstan or to the US to see their payload be launched. We're increasingly with Catalonia, with the rest of lots of Europe and around the world. Micro launches is really letting, it's allowing for this local infrastructure to actually see your payloads be launched. I think that's the, for me at the moment, most relevant, the most profound difference, because we obviously have this in the UK right now.
Xavier, from the perspective of aiming to build a micro launcher, how do you see the market?
Yeah, I think we have to come back a little bit historically. So probably the first company doing this is Rocket Lab. They started in 2007, sorry. And it's about what Jordi was saying before, right? This growth of very small satellites, very cheap, that a lot of people thought they need dedicated access to space. So the logical idea was to build smaller launchers, because the big launchers, so Ariane 5, for instance, class of launchers, were thought for very large satellites, so satellites that can be as big as part of this room, that weighed several tons, and these are what they call the primary payloads. And the smaller satellites were kind of left behind. And as you didn't have a lot of launch opportunities, they had to wait a lot of time to access to orbit. So you have satellites that are very cost effective, that have to wait a lot to go to orbit, and that cannot decide either the date nor the orbit they are going to, right? So you have this company, Rocket Lab, building the first small launch vehicles. They started in 2007, and they launched the first launcher, I think, in 2018, if I'm not wrong. So 11 years of development for a vehicle that has 150 kilogram payload capacity. So this is the need that was identified. But there are other ways also to move small satellites. So you can put a small satellite in a big launcher, and then you have what is called an orbital transfer vehicle, for instance, to deploy it where it needs to go. Or the small satellite can have propulsion on board to also go where it needs to go, right? There are other ways. So what happens here is that we need to look at the economics of a launch vehicle. And you have two big drivers of cost, to my view, in the economics of a launch vehicle. The first one is the hardware, so the rocket itself, that is mainly driven by the propulsion system that accounts for more or less 30% of the cost of the launch vehicle. And then you have the operations part. And the operations part are hard. And you have a lot of fixed cost. And now what we are seeing is that the model proposed by Rocket Lab is not working. Rocket Lab is proposing a price per kilogram that is around 10 times higher than SpaceX, for instance. And from what we can see in their accounts, they are losing money. So at Pangea Aerospace, what we saw is this need of what are we experts on? We're not experts in operations, we're experts in hardware, and more specifically in engines that can bring down the cost and increase your revenues. So our idea here, and we're not the only ones in the world, there is also a company, for instance, called Ursa Major in the US, very highly capitalized and so on, that is proposing to the market better engines. What does better engines mean? Higher efficiency, so you can bring more kilos into orbit, lower cost, and very sustainable, and of course, reusable. And we can propose this because we have IP that is unique. We have developed what is considered to be the most disruptive propulsion system in Europe right now, and this is our model. So to act on one of the two drivers of cost of launch vehicles, the part of the hardware.
So Xavier, you are an expert on operations.
Yes,
how is
and it's
space adapting here?
Not to contribute from a ground perspective on the discussion. One thing that we realized for so long at GTD is that the fact that we have only one spaceport, which is the CAG, and it's been, as most of the classic space has been dominated and controlled by the governmental for the public funding, that somehow made for decades infrastructures and operations lazy and obsolete. So in the new space, what we're trying to do for some time now, in the frame of operations, is try to propose something new, not only for infrastructure's point of view, but also from operations point of view, so we can contribute. Let's see how. Some way to say it is that the spaceport became like an airport for launchers, so we can host different launchers and can provide them with everything necessary to make their operations, to fulfill their campaigns and launch as quick as possible and as cost-effective as possible. So that's from one of the most important from European point of view, spaceport, and then again, and that shaking of the new space made that not only for the CAG but also for all the spaceports like the northern ones in Sweden and Norway, for instance, or in Scotland, as you, of course, you are better informed than us. They are also proposing something new, something more cost-effective, something more scaled down to the needs of the micro launchers, and that helps again changing the paradigm between the classic space and the new space, which not only helps. And I think it's the play here is not only help little companies or new companies enter the space domain and change things and became new actors in the domain. And as always, they boost also and tease somehow the big companies to accept changes and to accept the challenge, knowing that if they don't change, if they don't accept the challenge, they have the risk of becoming obsolete, and they maybe not now, but in the mid future or long-term future, maybe become overcome with the new companies. So they have to adapt themselves as well. If they want to still, when the pieces of the board fall again, depending on how they fall, if they want to still have control or some partially, totally control of the market, they have to still adapt. And either for one way or another, if it's us or it's they're changing, it's a contribution to move forward in that classical to new space.
So, Victoria, you've been involved in many spaceport development.
Yes.
How do you see this coexistence between, are we really prepared to coexist?
Well, all of the spaceports?
Yeah.
My personal feeling is, so we got very ambitious in the UK and we decided there was going to be 7 potential spaceports on one island. No, 2 islands actually. But, and remarkably, 4 have actually managed to attract launch service providers. So our Cornwall, Sutherland, Shetland and Prestwick. But the other 3 they've not just stopped. I think, so I actually used to, I was chairman of the board of one of those spaceports, Spaceport Machrihanish on the west coast of Scotland. And it's a former NATO base, so it's got a lot of what I call very cool concrete, great buildings and a very long runway and so on. And we just looked at it and just said, well, all these spaceports that have popped up, this new industry that's popped up in our country, it needs the support. It needs, the infrastructure to underpin it. So we decided to focus on R&D and testing and training of skills. And actually, one of the other spaceports, they're doing similar things, but not the same things. And so the way we see it is that actually all the spaceports kind of complement each other within, one industry. And I kind of saw the same theme. My Catalan's non-existent, but I saw the same themes reflected in the strategy that you have here. So it's, the launch of the rockets, that's very, very cool. That's the thing that makes the headlines. But actually, you can't just launch rockets. You need the students, you need the skills, you need the places to test things as well. And I think if you translate that UK situation globally, I think actually we'll get to a point that people will work out their niche, nations will work out their niche, what they're good at. And I think that you can actually get to this point where all of the spaceports start to coexist and complement each other.
Mm-hmm. At what point would you say that we are into, Xavier, you're already testing?
Yes, actually, just to complement on what you were saying, I believe that we're in a turning point right now in Europe. And the next years will be key to see where we're headed at, because, of course, the UK with the Brexit is a whole new situation. But for the rest of the continent, where we depended on 2 main launchers to access to space from Ariane Group and Avier, respectively, with amazing heritage, they dominated the commercial market for years and years, but they suffered the disruption of price from SpaceX for many reasons. Some people say that they are subsidized by NASA as well because they pay their launch 3 times more than when they offer it to the commercial market. But the reality is that we've been disrupted by SpaceX. And in the upcoming years, well, there is the Ariane 6 development that has to arrive to the market, but this launch vehicle is not reusable and it has a lot of questions. And you have a lot of different initiative, national initiative, mostly on the small launchers market, but some of them going over 1 ton of payload capacity. So I think it's important to see what will happen in the next years here as well. And coming back to your question on testing, for me it's fundamental, and even more for our business model, right? We want to build the best reusable, sustainable, and highly efficient and low-cost engines in the world to release it to the market. So it means that we're in a model that is more similar to aviation than all space in this regard, and we need to be very quick to reinvest part of of our income in R&D to continuously improve the reliability, the efficiency of our engines. And this basically means that we need infrastructure close by to go very quickly to testing. So I'm going to put an example. The engine that we developed it with a very low budget and in less than 2 years. And it's quite surprising. People thought when we presented the project, a lot of people even laughed at us and said that we were crazy, that was impossible, that NASA did a 15-year program to do the same, and so on. But we achieved it. We achieved it because, as Jordi said, we took a lot of risk and we implemented a lot of new technologies that are now enablers for a concept that was not possible in the past at this cost. Basically, we're talking about new materials, about additive manufacturing, about new cooling circuits. So we have a lot of IP generated. Some of it is patented, some of it is secret. But we need to go testing fast. So what we did before in Europe, we only have right now 1.5 infrastructures that are able to test with methane, so a cryogenic propellant. One of them is owned by Ariane Group, CNES, and DLR, so French and German Space Agency and Ariane Group. And the cost of testing there and the delays are humongous. So basically, we booked a facility 2 years before the testing. What does it mean for a startup that was 1 year old at the moment? Well, total uncertainty. Total uncertainty, but also a deadline on where we need to be at this given point of time. So it gives us a lot of focus, but this is not repeatable. This is not sustainable in time. We need to have infrastructure to go to test quickly, to be able to actually explode engines at some point. Some of you maybe not be very happy to hear, but it's a reality. We need to explode some engines to learn to go to the limits. And yeah, so this is our view.
You also talk about the reusability, and I remember, Eduard, the other day you were telling me that you were not certain about, you've also said that, but the reusability was the way to go. However, many of the new space companies, at least on the rocket side, they are going for it.
Yes, and it was, in fact, it's aligned with something that Professor Putsauri said about most of the best ideas or the easy ones are taken, so we have to try to be as much innovative as possible. And a decade ago, when Europe, with Ariane 5, which everybody also laughed at Europe because it was something built up among between different European countries, and was not the world was not used to the kind of achievement. People laughed at that. Sorry, and so you have to compete with people who master that kind of launchers or launch supply chain or fabricating that launchers. So the best way to find a niche and to be special and to have the fundings and to be something different and to pick another idea which is different from the ones that you are competing with, it's reusability. And that's why SpaceX and we think they took that idea, they mastered that with a lot of investment, with a lot of success. But there's still some points, some questions on which reusability is going to be really useful in terms of maintenance, cost effectiveness, launch campaign, because you have to do a lot of tests after launching. So it's more than being special and justifying why you are better or you have a different niche. You have that special idea that makes you really different from another competitor. Moreover, knowing that if you do the same, as the professor said, if you do the same someone's doing for the last 20 years, it's most probably you would never succeed in making the same thing better than those other competitors. So they took that, they exploited to an Excel, but now it has to really to assess if that's really the impact that they're expecting to have in terms of operations and cost and time of campaign, which is not strictly maybe it's not still assessed for the moment. It's something that Europe, and that's a debate, and maybe on the questions we can discuss afterwards. But the public-private kind of relationship that companies have with governments in Europe, and the fact that industry and supply chain it's quite effective. Reusability was not seen as an asset because inline production or recurring production was not an issue for European companies. So it was still cheaper to produce a lot of boosters than reusing a booster because of the mastering of the industry that you have in the continent. So that's why, but to add another argument, because a lot of people laugh at Europeans because we are far late from that kind of concept. No one said that's the concept of the future. Now it's beginning to be taken as the potential, or one of the potential lines of improvement for European launchers, like for Ariane 6. There are a lot of projects. Some of them, it's been GTD, for instance, has been involved, like the Callisto project and the Themis project. There's projects involved in developing first stage reusable for future Ariane 6. which will be not reusable at the beginning, but maybe in future flights will be reusable. And these are projects that the companies are beginning to try also to improve in that sense. And definitely something that is an axe of improvement for the future, but until now, at least it was not seen at least that important.
So we have a few minutes left because we had a bit of delay. So I would like to ask you a question to each one of you. How does the future spaceport, how will spaceports will look like in 10 years, 15? We don't move that much, that fast here, I think. Victoria, I think you are the more experienced here into future spaceport.
The future. Oh God, I don't know. I really don't. I think. Oh, blimey, it's a really big question. Very, very quickly, I think one of the great things, especially about the fact that we're using micro launches and small launches, is and I do have a point around this, that there's the risk is not less, but you can actually build spaceports closer to infrastructure. You can make it closer to, you don't have to stick it in the middle of the desert, in the middle of the jungle or anything along those lines. You can actually have it near things that are useful. So I think spaceports are going to become clusters a lot more for research, development, training, and so on. I think we also, because we're starting basically from scratch in Europe, unlike in the US where they've got heritage, we have the ability to adopt brand new digital technologies, automation, just to streamline processes and operations within the spaceport, hopefully.
On my side, I hope that they are as flexible as possible so that they can take different launch vehicles with different technologies, because we don't have yet a standard, for instance, in terms of propellants. I strongly believe that either methane or hydrogen, or the future hydrogen is very complex in ground, methane a little bit easier, but both propellants are green and facilitate reusability if compared with kerosene engines that are very difficult to reuse. And actually, this is one of the problems that SpaceX have. They have to swap a lot of engines. Just to come back on reusability, because sorry, I'm not close with it, but reusability economics are magical, honestly. You have so many factors to take into account. There is the factor that is called the payload penalty. When you need to reuse a launch vehicle or part of a launch vehicle, you are obliged to include systems that have a weight, so that have a negative impact on the payload capacity. So let's take the example of SpaceX. They fire their engine 4 times, one to go up, then to do what they call the boost back maneuver, so to cancel a little bit the horizontal velocity. Then when they are falling into the denser areas of the atmosphere, they reignite the engine a 3rd time for around 15 seconds, and then a last time to land. Each of these firings, they spend around 400 kilograms of propellant. And the payload ratio is around 1 to 5, 1 to 4. So it means that if they fire an engine for 10 seconds, 4 tons, around 1 ton of payload capacity that they are losing only for this firing. And if you don't fire an engine, you will have inflatable structures or other ways to land or to re-enter the vehicle. And this is, sorry, I'm going to sell, of course, my Aerospace, where the Aerospace really shines. Yes, it's true. It's a reality, because it allows you to have this precious bow shock that protects the structure and allows you to re-enter without doing a re-entry burn. So it facilitates reusability. But it's not the only factor that has an impact on the economics of reusability. Where do you land? How are you taking back the launch vehicle to the place where you refurbish it? How many operations of refurbishment do you need to do to certify again the engine? And this is very complex, and nobody knows apart from SpaceX. And because of the payload penalty, I think, and other reasons, industrial supply chain, in 2014 with the Ariane 6 program, it was decided not to go for reusability. But I personally, and this is personal, I think that we need to master reusability in Europe in order to properly understand what we're talking about.
And for the space in the future, we have, I will maybe give an example on that. We have an insight on because GT has been working in projects with Enginyera Spaceport. At the beginning, they had that kind of idea of the new space. They wanted to make a launch pad, and they wanted to make everything modular, flexible, and being able to host different operations for different launchers in only one infrastructure. That was the main idea. And of course, if you want to do something or make a difference, you want to go start from the top, and then reality puts down and puts you in your position. Yeah. But they tried that, and as far as we know, they already have 3 launch pads. So they succeed in making something more or less flexible and modular for one launch pad. But the 2 other launch services that they sign operations with them, they already have devoted launch pads only for them. So the modularity and flexibility, maybe it's allowable, maybe it's something interesting for some of the launch services, but at least not for the 2 of them that already signed contracts. So starting for one idea, it's something, and then more or less they put you in your level. For GTD, for instance, we've been looking for some time that kind of modularity and flexibility for operations and ground segment systems. And once projects that are ending this year and another one that's beginning next year, tackle that kind of question. So how far we can go with that flexibility, how much we can push a launch pad or an infrastructure or an assembly infrastructure or a launch range, a launch complex, how far we can push it to be as flexible as possible. Well, we still do not know. So most probably in the future, we go not for the top idea of making one launch pad flexible for everyone, and we won't have like in the decision in Kourou, a launch pad for every launcher. Maybe we have a combination of both. So maybe one launch pad can be potentially for trying, for reusability, for trying new launch systems, for new concepts, etc. But then most consolidated or more robust concepts that are more mature and they need their own specific fluids, mechanical operations, and campaign operations, they may require a devoted launch pad again. So we may fit in between the max and the min, most of the time we will fit in the middle.
Thank you very much. So we have 5 minutes for questions. If someone... tenim 5 minuts per preguntes. Tenim a la Mireia per aquí que ens ajuda amb el micròfon, així que no haureu de cridar. Aquí en tenim un.
Hola, Francesc Betorz, Rocket Factory. Una qüestió per Xavier. In English, sorry. There are many companies in Europe where developing a micro launcher, as you know. 3 companies in Germany, a couple in the UK, also in France, a couple in Spain. Do you think there will be enough market for all of them? Because, yeah, it's around 8 to 12 companies, but I don't know if there will be enough small satellites.
Definitely not. And this is why our business model is a bit different. And then, on a personal note, I think that Rocket Factory is probably the only company in Europe developing the technology that, in our view, is also in the right way. You need a good engine, and Rocket Lab understood this. So the first Electron vehicle has the Rutherford engine that is not very good, and they are suffering from it, and it's not the case of RFA. You have a closed cycle, good performances, and I think this is very, very, very important to drive down the cost. But again, it's not the only thing. Our whole idea is to have the best Euro over performance engine in the world, punto. And we are going to higher thrust also because we see that there is also a market there that is very, very interesting.
2 more questions, if you can. The second one, yeah, you talk about your advantages and your Aerospace engine, which is impressive for what you say. But which is the main threats that your company is the main threats for your company?
You are putting me on the spot here. There are several. I would say funding is definitely one of them. The political current landscape, I wouldn't consider it a threat, but it's a difficulty to navigate. That can be helpful, but it's still difficult. On the technological aspect, I'm not that very much worried because the MOP1, so the engine that we developed, is more difficult than what we're doing now. What we are changing mostly is to bring down the cost of manufacturing to minimum. This is our main objective now, so I'm not that worried on the technological threat.
Okay. And the last one, when do you expect the first launch?
This, it's not a question I'm answering.
Okay. Thank you very much and good luck.
Thank you.
And for Rocket Factory, when are you expecting the first launch?
End of next year. End next year.
Thank you very much. Alguna pregunta més? Allà n'hi ha una. No sé si l'hem vist. Crec que arriba el micro.
I hope it's not a silly question. It's about greenness and sustainability. I think I've heard a few concepts during this roundtable that point to greener access to space, closer, so development to launch place in closer distances, maybe new fuels, maybe reusability, micro launchers. Sorry, I'm not an expert on that. So my question is, could you wrap these concepts together? So are we going to a greener access to space? And if it's greener individually, but we multiply the number of launch or the number of satellites to be put into space, will this also distort the equation at the end?
That's a hard one.
That's a really difficult question. In the UK at least, so if you are applying for planning permission to build a spaceport, then there is always an environmental impact that you have to demonstrate. So it's the law. You have to. You know, everybody knows that space activity is inherently a little bit not green, but you know, but you have to demonstrate that you're limiting the impact as much as possible to still be able to do it. But I think also there is a political and a PR need to drive for better, cleaner practices, looking at new fuels, more efficient engines, the way that things are manufactured and so on, because the general public on the whole, who have no interest in space, they don't appreciate what it does, like, you know, we're not just sending rockets up for nothing. They actually serve a purpose, and very, very important humanitarian purposes and communications and all that sort of thing. So if you talk to the person on the streets, then they're like, well, you know, why are you spending all this money to, like, you know, harm the environment? So I think there's this need for us as an industry, and I include everybody within that, like launch sites, orbital operators, launch service providers, even, you know, the people who just use the data. I think you actually have to sort of like prove some green credentials, just because the opposition to spaceflight can be really, really big. So I know that doesn't really answer your question. I can't quantify it, but but I think there is an awareness between all of us that actually we need to improve it for a number of reasons.
Just to complement, the impact of the launch industry into greenhouse gas emission is completely residual. It's orders of magnitudes less than aviation or automotive, for instance, orders of magnitude. Then you have the question of how many emissions you produce while launching. Well, Ariane 5 is a nitrogen oxygen launcher, so 0. Kerosene is another topic. Methane is another topic. With biomethane, you can also achieve carbon neutrality in this regard. So the major part of the emission of the launch vehicle industry are emitting during manufacturing. Yeah. And this is also a good reason for reusability. Not the main one, because it has to be driven by economics, but it's also a good thing.
Yes, also to add something to that discussion, the thing is, as Xavier says, we are not the bad guys here in terms of how we contribute to the pollution. But the thing is, and the matter is, if we are selling that we are high tech and we are the most worked on the high technology, etc., if we do not know, if we don't do that, who else is going to do that? So it's mostly making an example of the aerospace is always in the top in the high tech, etc., and we're always selling that we are, etc., the high technology. So if we are not concerning ourselves in making something more greener and more sustainable, who else is going to do that if it's not us, who has everything available, or at least all the knowledge and everything we can to do? Another thing is, as you mentioned, what if we went to the new space, and we are imagining all those launches with all those nano satellites and everything. And we are launching constellations as it's in the press, 4,000 constellations of 4,000 satellites, 5,000 satellites, 10,000 satellites. It's not a matter of the pollution that's provoked during the manufacturing of the launches, that's what it is, but it's what's the pollution in the space, which is all the flying garbage sometimes, all the things around the Earth that maybe we do not master how to collect that again, we don't master how to make that down the Earth and what to do when it comes down to Earth again, with all that we produced and we launch up, and then we somehow have to make that down, or at least manage, if it's orbiting around the Earth, what's going to happen in 20, 30 years. If the projections, they really stick to the projections and really have those kind of constellations and that much of launch frequency, how it's going to become going out there. It's another part of pollution, not strictly here on ground, on Earth, but also outer space.
We will need 1 hour more to speak about space debris, and there are many astronomers who could say something here. So I think it's time. Yep. So thank you very much for your attention. Thank you very much for your participation. Y bueno, moltes gràcies.
Thank you. Thank you.